Hi, welcome to Lab 6. This lab is looking at relative dating in remote sensing imagery. Relative dating is just looking at which thing came first, second, third, fourth, not looking for specific ages. It's, 5 years old, 50 million years old. No specifics, but rather the order of events. We can do this in a few different ways with remote imagery or remote sensing imagery. Sometimes if you have a before and after photograph, it's really easy to tell the order of events because you can see beforehand and afterwards. A lot of times we don't have that. What we have is something like the image shown in the lab here, where it's a series of lava flows, and all we can use are the weathering, erosion, vegetation, things like that to determine the order of events. And that's what we're going to do in the lab today. In the lab, we've got the coordinates for the lava flow that I want you to look at. We've got the eye altitude. Hopefully you remember how to do that from the last two labs. I will review it in Google Earth, though. And we're going to introduce you to a new tool, the clock, that lets you look at past imagery in Google Earth. This is a wonderful tool. It's a lot like what you can do when you have other remote sensing software and images. And this is a way to look at before and after, but also, more importantly, to look at and find an image that doesn't have cloud cover blocking it or has good lighting conditions. And this way you can find an image that lets you see what you're trying to see. Now if we tab over to Google Earth, in this location right here, it's looking really nice. But I'm looking at a past image. I'm not looking at the most current image. To do this, I clicked on this little clock up here on the top bar, Show Historical Imagery. If I turn it off, you can see the image changed. It jumped to the most current image. Turn it back on, and now I'm seeing an image with clouds. That one still has clouds. This one doesn't have clouds. This one's very dark, has minor clouds. So you can see a whole series of different images. Every little white bar on this long blue bar is a different image. And so you can scroll through, check different dates. This can help you bracket an event if you see a before and after. So you know, hey, everything that was in the 2004 picture is before this thing that is suddenly visible in the 2006 picture. And I know it happened within that 2-year time frame. It's still relative dating because you don't have a specific exact date, but especially in geology, having something bracketed as happening within a 2-year period is pretty accurate. Now if we look at the lab here, we can see one of the ways that you're going to do the relative dating is by the color of the rock. In Hawaii, the lava flows are all basaltic. This is a mafic rock, high iron and magnesium content, normally very dark, approaching black. And the longer it's exposed to the atmosphere and rain, the more and more weathered it becomes. The more weathered it becomes, the lighter and eventually brownish it becomes because that iron is oxidizing. The rock is effectively rusting. So you can see a scale here. Youngest, this is the newer, fresh stuff that came last, will be black or dark gray. Depending on the sunlight conditions at the time of the photograph, it may just look like a very, very dark brown. So you want to keep that in mind too. And then as you get older, this is going back in time, back towards the first lava flow, they're lighter and lighter, more gray, light gray, more brown and light brown, approaching tan or rusty colored. You can also look at where the lava flow terminus is. This is where the front leading edge of the lava is. If it doesn't go all the way down the mountain, you can look at what's the downhill direction, where's the edge of the lava flow. This helps me tell which is newer. The one that's on top flowing downhill is newer or younger than whatever was underneath. You want to be careful though, downhill is not always down your screen. Now, another tool in Google Earth that you want to be using in this lab is the place mark tool. This is what puts little yellow push pins on your image, and you can label them, and this lets you identify the youngest and the oldest and the things that are in between by placing push pins on them. You can see right here, right along the top, is Add Place Mark. Whenever you click it, it places it exactly in the center of the screen and pops up this little window. Now you can put in a label like oldest 1, because that's the numbering scheme. The oldest, the first one to appear, will be number 1. And hit OK. And now it's placed there. When you grab with the left mouse button, it doesn't move the pin, it just moves the screen. If you don't like where you placed it, you can right click it and hit delete. Hit OK, and now it's gone. When you click it before you hit OK, now you can move it around because it has that little yellow box around it. Very useful, lets you place it where you want on different lava flow if you didn't have it centered. Or you can hit cancel if you don't want it there. So that push pin is going to be needed in this lab. Once you have everything labeled, I'll show you an example coming up here. You want to either save the image from Google Earth or use the snipping tool. I really like the snipping tool. It's really easy to do, kind of like this. You select the area you want, hit edit, copy, and then you can paste it into your lab report. Of course, this only works if you're on a PC. If you're on an Apple computer, you'll need to save your image or do some other kind of screen capture to get your image to put into your lab report. In your lab report, and this one does require a real lab report. I know the last two Google Earth ones did not. But this one, you'll write an introduction, methods. In the methods, you'll talk a little bit about using the remote sensing images in Google Earth and a little bit about what your method was for choosing oldest and youngest and so forth. You'll include your image from Google Earth with your push pins identifying the relative ages of the lava flows, and a conclusion where you discuss what you think about your capability to use remote sensing to do relative dating in the future, or even in person if you were hiking around on the side of the mountain, for example. Would you be able to walk up to a lava flow overlapping another one and tell just by looking at the weathering which one was older? Now, one of the things you want to do is make sure that you use a vertical exaggeration of 1. Now, when you flip it up to vertical exaggeration of 3, it might be a little easier to see certain things, but lava flows are not very thick in Hawaii, or at least not in the area you're looking at. So each individual flow is not thick enough to really show in the 3D imagery. So even with a vertical exaggeration of 3, that's not going to really help you very much. So you can't just go into Street View, look at the edge and say, oh, this one looks higher than the other, so it's younger. Even when you're looking straight down on it, for example here, a lot of times the darker rock just automatically looks like it's inset and lower. This is an optical illusion created by the color. You can see here, at least to my eyes, it looks like this is deeper or lower elevation than the light rock. However, knowing that the dark rock is younger, it's less weathered, it has to be on top of this older rock. This is actually an edge and a terminus of this younger lava flow. This is another example of downhill is not always down on your screen. In this case, downhill is towards the top right. In your area of interest for this lab, downhill is to the north-northeast. If you pan out to a much higher eye elevation, you can see the center of the volcano and see which way is downhill in all directions around that center, and then you can easily see that down is to the north-northeast in your area. But when you're zoomed in close, it's not always easy to tell. Now, this is an example of how not to label your lava flows. It's got an oldest and a youngest, but they don't have any numbers. And then the rest of the labels just say next. How am I supposed to tell, which next is next? This is why I want you to have numbers. Oldest is 1. In this case, there are 5 push pins. So youngest would be number 5. And, this one here would probably be number 4. Out of the ones labeled, it's the second darkest. This would be number 3, and this would be number 2. So we'd have oldest 1, 2, 3, 4, 5. Of course, there are a lot more than 5 lava flows on the screen right now, but of the ones with push pins, that would be the order, that would be how they should be labeled, not what's actually labeled. So this is a correct way of labeling them. This one is oldest, it's the lightest color out of this area. The second oldest, it's slightly darker, and then this is the youngest of the labeled ones, because it is the darkest, least weathered basalt right there. So if we jump over to Google Earth real quick, I showed you the way to look at the historical imagery. I showed you how to look at the push pins. Make sure you check your tools in case your vertical exaggeration is still on 3 from your last lab, just like mine is. So I changed that to 1. I hit apply. It seems to change my elevation, plus I'm not even at the site for the lab. Here it is. And so you can see here, but I'm not in the right year. Switch it back to 2002. And now this is your area that you're going to be adding your push pins to. If you have any questions, of course, email me, and I'll be able to help you.